Just like linear equations, quadratics can be in different forms. So we've already talked about standard form of a quadratic function, and we know that is y equals ax squared plus bx plus c, where a is never 0, okay? Because obviously if it was a 0, then we would have no quadratic. So this is our standard form. We've talked about how to graph from standard form. So remember our procedure. We want to find our axis of symmetry first, and we do that by using our formula. X is equal to negative b over 2a. We would then plug in whatever our value of our b is and our a, find our axis of symmetry. Then we would use that value, plug back in, and find our y, which then will give us our y value for our vertex. Once we have our AOS and our axis of symmetry marked on the graph and our vertex, we can then make a table and pick smart, symmetrical, mirrored points to find enough points to then graph. So what this form is the best for is to be able to quickly see the y-intercept. So here's an example of a quadratic function, 3x squared plus 12x minus 15. So if I wanted to quickly find the y-intercept, where it hits the y-axis, or the vertical intercept, as you may see it called sometimes, I can know when y-intercept, I know x is always 0. So I can plug in 0 for these x's here. Well, I know that 0 squared is 0 times 3 is still 0, and 12 times 0 is 0, so I know that my intercept is negative 15. So it makes it really convenient to find the y-intercept. That's a quick method to be able to use to find that. Now, two other forms we're going to talk about today is factored form is our next one, and we have factored quadratics already this year when we learned about polynomials and factoring. And this is just the same function, the 3x squared plus 12x minus 15, but it's in factored form. So I pulled out a greatest common factor of 3, and then I factored down and got the factored form. Now this form, its kind of general form is y equals a. A is still the same value as a is in a standard form. It's still the same number. It still controls whether it opens up or opens down. So, of course, if it's positive, it opens up. If it's negative, it opens down. It still controls how wide or how narrow a parabola will look. The difference is it's in factored form. So, x minus, and this is a number or a root where it would actually hit the x-axis, and x minus q. Now, sometimes you'll see R1 and R2 used for p and q instead. It just is telling you it's two of the roots. Okay, it's the root. So you don't always have two of them because sometimes you don't have a solution. So remember that. So here's an example. This is actually the same quadratic as the one above, but in factored form, as I said, and this is good for finding the roots. So in factored form, the part that's in parentheses, the way we would think about it is if I want to know where they hit 0, I would actually say, well, x minus 1 equals 0 and solve for x. Well, plus 1, x is 1. So notice this was a negative, but my solution's a positive. Same thing with x plus 5. I want to know where it's hitting the x-axis, the root or the intercept or the solution, and I would solve. So minus 5, x is minus 5. Notice this was a positive here, but our answer is a negative. So if you think about in the formula itself, they have to have negatives. So if I have a negative value here showing, and I know that's part of the formula, so my solution is 1. So it's opposite of whatever the value is there. So these are really good to find roots. Really quickly, you know immediately where they hit the y-axis. And we'll talk a little bit of how to graph these shortly. The third form is called vertex form. And just as the name intends, it is very good for finding the vertex. So its general form is A, and again, A is the same as it has been in the last two forms. We have x minus h, new letter, plus k, and notice we have this little piece squared. Well, h and k are actually the vertex. And we know that a vertex is the x value and the y value. So h takes place of x in this form, and k takes place of y in this form. Not the y-intercept, the y value on the vertex. So here's an example. These are all the same function. This is just in standard, then factored, and this one's in vertex. We have 3, so this is our A. We have x plus 2 squared, and 1 minus 27. So these are very good to find our vertex. Now, just like the previous one, we have to look at what our general formula is. Our general formula says there has to be a negative there. Well, in our problem here, we have a positive. The only way to get a positive is because I put in a negative. So actually my x value in this one would be a negative 2. And then when I plug this in, and think about what, if you're not sure and you get confused, we're thinking about what's going to make this 0. What's going to make this section here 0? Well, if I put a negative 2 plus 2, I get 0. And 0 squared is still 0 times 3 is 0. And then I have a negative 27. That tells me my y, or my k, is negative 27. So if I want to write that as a vertex, as h, where it goes, here is my h, I have a negative 2, and my y, I have a negative 27. So this would be my vertex. Now, once I have my vertex, I also know what my axis of symmetry is, because my axis of symmetry is always the x value of my vertex. So it helps with lots of things, but these are very quick to find the vertex. You just have to look and understand the formula. So let's talk about how to graph from factored form. So we're not going to talk about how to factor again right now. We'll get back into that when we solve, but we're going to talk about how to actually use this form and graph onto graph paper. So the very first thing we have to do is find the roots or the zeros. Remember, they can be called solutions or x-intercepts. And we're going to look at what is already in the little bubbles. So remember, it's going to be the opposite. It's going to be what makes this 0? Well, a positive 7 and a what would make it 0? Well, a negative 7. So it's just the opposite of what's here. So one of our roots is negative 7, and the other root is negative 1. So we can think about if we were graphing and we had some labels here. We would have one spot hit at negative 1, 2, 3, 4, 5, 6, 7, and 1 at negative 7. This A tells us that it opens up. So we know it's going to open up. So that kind of helps us with our solution. So we can't just have roots. We got to know where the vertex is. So we've got to find the vertex. Now, to find the vertex in this form, we can always take any of these forms and multiply them back and get into standard form. However, that's a lot of extra work. So we want to find the vertex. Now, the vertex is exactly between the two roots. So we're going to find the average of them. So negative 7 plus negative 1 and divided by 2, because we have two values. So negative 7 plus negative 1 is negative 8 divided by 2 gives us a negative 4. And once we know the negative 4, that tells us our AOS. So we have 1, 2, 3, 4. So our little AOS would go right through here. And now we can plug this negative 4 into our problem and find our y value for our vertex. So we could have 2/3 negative 4 plus 7, negative 4 plus 1. We'll go ahead and simplify. I'm going to leave my fraction to the end. I'd have 3 and negative 3, which we know is negative 9. Because this is all multiplication, I can do it any way I want. Doesn't matter order of operations because it's all multiplying. And then I'm going to multiply. So we would have 2 times negative 9. Now I would probably cross reduce first. So 1 and 3, and I'd have a negative 6. So I know the other part would be negative 6. And my vertex is negative 4, negative 6, which might be around, roughly around there. And then I have enough to kind of get my image to graph there. All right. So you may have one that's like this in factor form, and it may just ask you, what is the vertex? This is not graphing. They just may want to know what the vertex is. So remember this still the same way. The vertex is halfway in between our two roots. Well, we got to know our roots. So we think, what can I put in here for x to make this piece be 0? Well, if I have a negative 5, I know I can add 5. So I know one root is 5. What can I put in this one to make it 0? Well, -1. So those are my two roots. So I think about if I were to graph this, one's at -1 and one is at 5. There's nothing in front of here, no a value, so I know it's just a 1, and it's positive, so I know it's going to open up. So I can think about halfway in between, because these are mirrored points, halfway in between these two is going to be my vertex and my AOS. So I would do 5 plus -1, which gives me a 4 divided by 2, which is 2. So I know 1, 2, that my AOS is at 2. And now to find out what my y value would be at my vertex, I plug 2 in for my x. So 2 minus 5 and 2 plus 1. Well, this is a -3 and this is a 3. I would get -9. So my vertex would be 2, -9. All right. Let's look again how some important things of just finding some important things in vertex form. So our a value, be able to spot, is a -2. That tells me immediately, because it's negative, that it's going to open down. My x value, think about whatever is here. We know this part has to be a negative. It's part of the problem. So if it's already part of the problem, we think what could be put with it to make it 0? Well, it's a +5. Or you can think opposite of whatever's there. And then plus 10, and we know in our formula it's plus, so we know our y is 10. So then to find our vertex, it's just our x value and our y value. So 5, 10. Let's do one more of those. So our a value, 4. Our x value, so what goes in here to make this equal 0, -3. This should be a plus something, and if it's just negative, we know the whole thing is -5. So our vertex is -3, -5. Now, let's talk about if we wanted to take standard form and we want to move it to vertex form. Now, there's lots of ways to do this, and we're doing very simple to the point today, but just to get it into a form where we can write it pretty simply. So we always want to look and kind of see what our a is, because remember our vertex form has an a in it as well. And if we remember, let's make a quick copy here of our vertex form. Do a quick copy of that, and we'll move it down here so we have it again. Shrink it up just a little tad. So remember, this is our vertex form, what we're going into. So we want to know what our a is, because we may have an a to put out there. All right, so our a, I'm going to go ahead and write. It's a 1. Now we're going to find our axis of symmetry, because we're going to need to know that to kind of help us move in that direction, because axis of symmetry gives us our x value, which is really our h in this point. So we're going to find a -b, so a negative, and our b is -12, so a -12, over 2 times a, which is 1. This becomes a +12 divided by 2, which is 6. So we know that the x, or the AOS, is 6, x equals 6, which is also the x value of our vertex there. That also tells us what our h is. Remember, this is h, and this is k. So our formula has a negative in it. We know it stays there. This is a +6, and it'll go into our formula shortly. Now we have to find k. So same thing we do when we deal with standard form. We plug in what we know for the vertex, x value, or the axis of symmetry, into our formula. So we're going to use 1 times 6 squared minus 12 times 6 plus 44. And of course you can use a calculator. So this would be 36. And we'd have 60, 72, and 44. So then we would go ahead and add those together. 36 and 72. And remember, if you have to do longhand, you would work this out and then find our value. So let me pull up our calculator to show you how you could use your calculator to do that. Does not want to cooperate. There we go. All right, so if we're going to use our calculator, we could then put in 36 minus 72 plus 44, and we would get 8. So now we know that our K is 8, or the Y value for our vertex. So now let's take what we know and write it in this form. Y equals, A is 1. If it has a 1, we could put a 1 there, or we could leave it because we know it's a 1. X minus 6 squared plus 8. And this would be in vertex form, and this was in standard form. So they're the same function, just in different forms. All right, let's try another one. Now, if we're going to graph something, we are going to need to know a little bit more. So this one, we're going to go a little bit deeper in how to graph it. So we are first going to write down our A. Our A is -2, because that's going to help us get it to that form. We're going to find our AOS, so -2, because ours is a +2, and then 2 times -2. That gives us a -2 and a -4, which is a +1/2. So we know our X value is 1/2. Now we would plug that back in and find what our Y is. So if we plug it back in, -2, 1/2 squared plus 2 times 1/2 minus 3, and this is where we'll use our calculator. So -2, use your parentheses, 1 divided by 2 squared, and then plus 2 times 1/2 minus 3. We get a -2.5 for our value. So if we want to then write it in our form, we have to think about what our form was. Remember what our form was, AX minus H squared plus K. So now we would write it. Y equals, our A value was -2. X minus, put in our H value, is 1/2. That quantity squared. And then minus 2.5. That would be in vertex form. Now, if we were graphing this and we found the AOS, that would help us, and we found the vertex, that would help us have a AOS and a vertex, and we would then have to find another point. We could pick any point. You want to pick something kind of close. So if I have a vertex and my AOS goes through -1/2, I might pick 0. And so I'd plug in 0 into my formula and solve for Y, and see that gives me another point to then be able to graph. So when you're doing some of the cons, then you'll need to make sure that you have the vertex correct and another point to be able to get the right spots. All right, so let's continue. Practicing, go back and refer to these notes whenever you need to.